have some fun looking at the mid-segments of triangles in the coordinate plane. Let's check out an example together. So the vertices of triangle ABC are A, -5, 3, B, 3, -1, and C, -3, -3. And I drew the picture right here. Now, we're told that D is the midpoint of segment AB, and E is the midpoint of segment BC. Here's a challenge. Let's see if we can show that segment DE is parallel to segment AC, and that the length of DE is equal to 1/2 the length of AC. Then, in fact, let's actually also sketch the line DE. Okay, so where do we start here? Well, the first thing I have to do is I'm given the fact that E is a midpoint of BC and D is a midpoint of AB. In fact, when I just said it a moment ago, you'll notice I said the D part first. I wrote it this way because I wanted my name in this particular math lesson. Thank you very much. Thank you. Okay, so let's take a look at what we got. So D is the midpoint of AB. So here's AB, and so the middle of it, somewhere over here, how would I find that? Well, all I have to do is use the midpoint formula, which is just a very fancy way of saying you want to find the average of these 2 points. So you average the x values and you average the y values. You take the x values, add them, and divide it by 2, and that's the average x. You take the y values, add them up, divide it by 2, and that gives you the average y. Couldn't be any easier than that. And when you try that, you see that the midpoint of AB works out to be -1, 1. So where in the world is that? -1, 1. Well, in fact, that's right here where I was pointing. Look at me. I got lucky. So that is D. I'm going to call that D. And now what about the midpoint for BC? Where's that? BC is over here. And that midpoint looks like it's right here, in fact. And we can do that really easily, again, by averaging the x values, add, divide by 2, averaging the y values, add, and divide by 2. The midpoint between 2 points is literally the average of the points. Couldn't be any easier than that. And so when you work all that out, again, we see exactly what we thought, which is we get 0, -2, which is exactly what I had predicted. And we call that E. And so if we connect them, we're going to get ED, or as we like to call it, DE. Okay, so here we go. I'm doing it live. There it is. So now, what do we want to prove? Well, we want to prove some basic facts about this particular line segment. First, I want to prove that it's parallel, in fact, to the opposite side here, AC, and then I want to prove that its length is exactly half of this. Well, since we know all the coordinates, this is actually not so hard to do. All I've got to do, first of all, is compare slope of this and slope of this. If the slopes are equal, then we know the lines are parallel. And finding slopes, that's easy. That's just the change in y over the change in x. And so for DE, if I want to find the slope, I would just take the y values, and so I take, for example, -2, and subtract off the y value here, which is 1, so -2 minus 1, and then take the x value here, which is 0, and subtract off its x value, which is -1, so 0 minus -1, and so it works out to be -3. Notice that it is negatively sloped because it's going down, so that's good. It's going down. Now, what about the slope of AC? We would do it the exact same way. And when we compute the slope of AC, we would take -3 and subtract 3. We would take, again, -3 and now subtract -5 for the x's, and it works out to be exactly -3. Since these slopes are equal, so since these are the same, that implies that DE is parallel to AC, which is what we want. And so that takes care of that little challenge, which is great. Now I want to show you that this length is actually half of this length. And so how would I do that? Well, I would now just use the distance formula, which is just the Pythagorean theorem in disguise, to find the distance between these 2 points, the distance between these 2 points, and compare. So of course the distance